Least squares regression method. Here's how to find an equation using this method. I know these steps look kind of complicated, but once you get into it, it's just a lot of calculations. Get a calculator. So you're going to build an XY table from the data, and you're going to add a couple of extra columns. So you're going to end up adding 3 or 4 or 5 columns, depending on which way you go. But you want to add columns for x, y, and x squared. Find the sigma, or the sum, for each column. N is the number of data points, and then we're going to find M and B using these two formulas. All right, I know that looks scary, but every time you say sigma, every time you see that Greek letter sigma, it just means the sum of all of the numbers in your column in your table. Correlation coefficient, all right, we're going to find R squared using one of these two formulas. And I messed up. I don't know how this happened, but the little negatives right there, I don't know how that ended up there, but get rid of those negatives. Those are not there. I mean, you are still doing some subtraction, but there are all of these little negative signs. Cover those up. Those are not supposed to be there. Okay, there are 5 of them, I believe. 1, 2, 3, 4, 5. 5 of them that should not be there. But those formulas are going to give you the R squared coefficient. Now, a couple of things about that. Formula 1 looks a lot more complicated, and I suppose it is, but believe it or not, it's less work to use Formula 1 than it is to do Formula 2. All right, Formula 2 has a lot going on behind the scenes. Namely, there's something called Y bar and Y hat. All right, Y bar is the average of the Y numbers. Y hat are the values you'd get by plugging in X numbers. All right, so basically Y hat is when you plug in each of the X numbers into the equation that you would have found up here. All right, your number 4, your regression equation. So there's a lot going on. I get it. It's kind of tough. But let's look at an example. That's the best way to learn, I think. You'll want a calculator because there's a lot going on. Your iPhone app is not a very good calculator, so you'll want something better than that. Number 3A says find a least squares regression model for the following data. All right, so one of the first things we're supposed to do is add a couple of extra columns. So I want to add a column for X times Y, and I'm going to add another column for X squared. And I don't need a calculator for X squared. I can do that in my head. Just look at the X number and square it. 1 squared is 1, 2 squared is 4, 3 squared, 4 squared, 5 squared. Try to keep them lined up. 6 squared, 7 squared. I don't need a calculator for that part. All right, but you will want a calculator for the for that third column, X times Y. So we want to do X times Y. So 1 times 1.5 is 1.5. So let's do 2 times 3.8 is 7.6. 3 times 6.7. You can probably go faster than me on this, is 20.1. 4 times 9 is 36. 5 times 11.2 is 56. 6 times 13.6 is 81.6. Do you guys understand what I'm doing? I'm trying to go a little bit faster. And 7 times 16 is 112. All right, so build an XY table for the data, add columns for XY and X squared. So I did that. That was step 1. Step 2 says find the sigma for each column. Find the sigma or find the sum for each column. Okay. So I'm going to go down here and I'm going to find the sigma for each column. So literally all that means is I'm going to add up all those numbers. 1 plus 2 plus 3 plus 8 or plus 4 plus 5 plus 6 plus 7. Okay. 8 plus 8 plus 8 is 24 plus 4 is 28. 28. Add those numbers straight down, you get 28. Okay. Add these numbers straight down. You don't need to see me do that on a calculator, do you? Add those numbers straight down. Yes? Okay. 1.5 plus 3.8 plus 6.7 plus 9 plus 11.2 plus 13.6 plus 16, 61.8. Okay, so the sigma or the sum is 61.8. I'm not typing all these numbers in. Add them straight down. Okay, add all those numbers in, and you get 314.8. Add all of these numbers, and you get 140. Those are the sigmas. Don't be scared of the Greek letter sigma. It just means sum. Those are the sums. So back to the steps. Step 2, find the sigmas. Done. Step 3 says find n, which is the number of data points. And so sometimes people are confused by this, but literally this is the easiest step because all this means is there's 1, 2, 3, 4, 5, 6, 7 data points. N equals 7. All I did was count up the number of data points in my problem. N is 7 because there are 7 sets of numbers, 7 data points. So that was find n. Now 4 says find m and b using the formulas below. So this is the hard part, obviously, because we have to use those formulas. All right, so I'm going to recopy the formulas. Hopefully I can write this small enough to fit. Let's see, let's go. All right, so the formula for m was n sigma xy minus sigma x sigma y over n times sigma x squared minus parentheses sigma x squared. Okay, this is literally just plug and chug, all right? So when we look at our numbers here, everything we need is up on the screen in my table, all right? So n was 7. So the first number I'm going to plug in right here is 7. So this number right here is 7, this number. Okay. I'm going to scoot it down. And this number right here is also 7. Now, the next thing I need is sigma xy. Sigma xy is this number right here. That's sigma xy. That's the sum of that column. So I'm going to put right here 314.8 minus I've got sigma x. Sigma x. Where am I at here? Sigma x is sigma x right there, 28. Then I've got sigma y. sigma y, sigma y, 61.8. Okay, what else do we have here? You look at the bottom part of the formula. Sigma x squared. So where was x squared? This was x squared. Sigma x squared is right there, 140. Sigma x squared. The sum of the x squared column was 140 minus. And then this one's kind of weird because it looks like it's the same thing, but it's not because of the parentheses. It doesn't say sigma x squared. It says sigma x squared. Okay, so when I'm looking at sigma x right there, sigma x is sigma x right there, 28 squared. Not the same thing as sigma x squared is not the same thing as sigma x squared. So I want sigma x, which is 28, and then I'm going to square it. Okay, so I think the hardest part is just keeping your eyes from going crossed there. You've got a lot of little numbers. You got to plug them into the right place, and now you've got to plug them into your calculator appropriately. So let's just look at the top. All right, we've got a calculator. We've all got calculators. We should have calculators. And I don't do something like this that's this complicated on an iPhone app. I want 7 parentheses 314.8 minus 28 times 61.8. And I'm going to do it in parts just because I want to make sure that I'm in good shape. 473.2, that's the top. So that's the top, 473.2. Now for the bottom, 7 times 140 minus 28 squared, 196. That's the bottom. Okay. Now I just need to divide those two numbers. 473.2 divided by 196. And we get this big long decimal. I'm gonna end up rounding off. Let's round up to 3 decimal places. 2.414. So m is approximately 2.414. Okay. And that's our slope. Now we have to find our b number. Okay. B number is a little bit easier. Look at your equation. The equation for B was this one over here, sigma y. Starts with sigma y. B equals sigma y minus m times sigma x over n. Okay. So sigma y was this number right here. Sigma y was 61.8. So we've got 61.8 minus m is the number that we just found. We just found m was 2.414. So 2.414. Feel free to use more of the number than just 3 decimal places. But if we can do this, I mean, I'm going to be fine if we can just round to 3 decimal places. But that's your m number. Now we need sigma x. And sigma x was this number right here. That was sigma x, 28. So times 28 over n was 7. Remember that? N was 7, the number of data points. So this one's a little bit easier to calculate. We've got 61.8 minus 2.414 times 28. Oh, I typed 141. Thank you very much. Yeah, 61.8 minus 2.414 times 28. Hopefully this will come out right. Negative 5.792. Okay, roughly. I think I've got on my page negative 5.8. I think because I used the entire 2.414 number. If we used 61.8 minus 2.414, 285, 714, 286. If we use everything we've got, times 28, that's basically negative 5.8. So depending on how you round, that's negative 5.8. I'm not super concerned about how accurate you are with that, but I'm going to call that negative 5.8 right there over 7. And so then take that number divided by 7. Negative 0.829. So B is approximately negative 0.829. Now, what in the world? Do we even remember what we were trying to do? Find a least squares regression model means equation. Ooh, what? For the data. We're trying to find an equation. Well, okay, great. We got M and we got B. So all we have to do now is write down the equation. We've got it. Y equals 2.414x minus 0.829. That would be an equation for this line right here. All right, that line is going to be a pretty good fit for those points. All right, questions? Now, check it out. Okay, I want you to go to this spreadsheet. Okay, because this spreadsheet is going to do all the math, all the calculations for you. All right, all you have to do is enter in the data points. So let's see this, and we want to enter in 1 and 1.5, 2 and 3.8, oops, 3 and 6.7, 4 and 9, 5 and 11.2, 6 and 13.6, 7 and 16. Hopefully that works. Okay. Notice your sums, 28, 61.8. It does all your sums for you. And it also comes up with this equation. I've got it rounded off to 4 decimals, but 2.414x minus 0.829. That is what it is. All right. So that's kind of nice that does all of the grunt work. That does all of the heavy lifting for you, and you don't have to do all of the stuff. Okay. So we go back and we look at the next question. Part 3b says find the r squared value for that equation. Well, can you copy over those numbers into the chart? There are a couple of different ways to do. There are a couple of different ways to do this. We don't have time. Is that what you said? There are a couple of different ways to find that r squared value. So if you go back and look, it says either add a column y squared and use formula 1, or add columns this, this, and this and do formula 2. Now it seems like I don't know, they're both kind of difficult, but all of this says formula 2 is divide these two sums. Okay, and so if you're looking at this chart, all right, y hat minus y bar squared and y minus y bar squared. If you're looking at this chart, all you have to do is divide this column or this number and this number. That's it. That's how you find that R squared number, is you divide those two numbers. But anyway, that's where it's going to be down here in the bottom. This green number, that's your R squared value. And that tells me that's really, really, really close to 1. 0.999 basically is really, really, really close to 1. And that tells me that this model is really, really good. There's a really good approximation of those dots. Those dots are going to be really, really, really close to that line. So if I was going to do this problem by hand, what I would do is probably, I think if I had to do this by hand, I'd just find this y squared column and I'd do formula 1. And you can copy this from that spreadsheet if you want. I'm just squaring the y values. That's a 5. Guys, still have 2 minutes left. So I need y squared, and I could fill into this formula. I'll leave that up to you to fill those numbers in, but you're going to get 0.999. That's your R squared value, and that's a pretty good number.